All right, so I wanted to make a quick video just revisiting the paper exploration in case if you were absent or maybe you just want to see it one more time to make sure that everything that we thought was important in class makes sense. So the first part of the exploration was on a square grid paper and you were asked to draw squares. So I believe the first square had a perimeter of 4, means that when I go around the square, the total length should be 4. So 1, 2, 3, 4. So every side length would be 1. I'm going to come back to this square. The next square had a perimeter of 8. So that means that the total length of the border should be 8. So I need to go 2 in each direction. So 1, 2, 3, 4, 5, 6, 7, 8. So each length is going to be 2. And then I'll just jump to the biggest one. I know that our largest one, I think, was 5. Like 5 by 5. It had a perimeter of 20. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember, you're not counting the number of dots. You're counting like the steps between the dots. So this is 1, 2, 3, 4, 5. Okay. And then you were asked to find the length of the diagonal. And the reason why we're working with squares is because if we divide squares in half by creating a diagonal, we actually now have a 45, 45, 90 triangle. So this is the triangle that we are very interested in. So here it is. All right. So I am going to do a couple of things. I'm going to mark my legs congruent, and I'm going to mark my 90-degree angle because it's a square. And squares have 4 right angles. Squares are also rectangles. Okay, so then using Pythagorean Theorem, which we are allowed to use because these are right triangles, we can find the length of the diagonal. Right, so this is 2. So if I take a square root, I get the hypotenuse of my first one to be square root of 2. And then in this one, we would set up the Pythagorean Theorem. And 4 plus 4 is 8. And when you square root and you simplify, you actually get 2 root 2. And the last one, if I do 5 squared plus 5 squared equals c squared, you would end up with square root of 50, which turns into 5 root 2. And at this point, I'm hoping you see the pattern that in every single one of these triangles, the legs are always congruent, and then the hypotenuse is a little longer, well, longer than the leg by root 2. So if you look at compare the numbers, you essentially are almost taking the length of the leg and you multiply it by root 2 in order to get to the length of the hypotenuse. And then the other exploration we had was on the isometric paper. So here we were drawing equilateral triangles. So the first triangle, I think, was perimeter of 6. So I need to go 1, 2, 3, 4, 5, 6, which makes each single side length of 2. And then, I did want to do one more thing with squares before I forget. I do want to make sure that we remember that these are 45-degree angles because this used to be a 90-degree angle and we bisected it. So these are 45. So these are the yellow triangles are 45, 45, 90. Okay, so here we got a square, and then I think our largest one was 6. 1, 2, 3, 4, 5, 6. And I chose even numbers for the side lengths on purpose because when we have to split up the bottom side, it's a lot nicer to split it up and half of the number is even. Okay, So equilateral triangle, we actually know that these are all 60 degrees from earlier parts of geometry. And we were asked to find the altitude, so which is the height. How tall is your triangle? So I'm going to take the angle on the top and I'm going to erase it because it's not 60 that we're really interested in. We're interested now in half of that because now that 60 got bisected. And once again, we're not really interested in the whole equilateral triangle. We are really only interested in the part that is the right triangle. So I'm going to highlight, this is sort of what we're looking at. So we're only really focused on this. And in order to help us figure out the relation between the lengths, I'm going to go ahead and think of the bottom side as like partition, right? So it's broken up in half. So 3 and 3, or in this case, 1 and 1. And we have asked you to find the height or the altitude of the triangle, so which is the black segment in the middle. So using Pythagorean theorem, just make sure that this right here would be your C, because this is your longest side now. So we could do 1 squared plus b squared equals 2 squared. So b squared would be 2 squared minus 1 squared, which is 3. And then when you square root it, it would be root 3. And then in this triangle, again, 3 squared plus b squared equals 6 squared. So b squared would be 36 minus 9. And that's going to be 27. So square root of 27 can be simplified like we've been simplifying radicals, and it would be 3 root 3. And then what I'm going to do next is I'm actually going to go ahead and erase this part of the triangle that no longer needed, just so we can focus. So here what you see is the relationship between the shortest leg. In our case, our shortest leg is going to be the one on the bottom. It's always across from 30 degrees because 30 degrees is your smallest angle. And earlier in the year, we learned that shortest sides were across from smallest angle. So here you go. So our shortest side is 3. And then if you look at the hypotenuse, we notice that it is twice as long. The hypotenuse is twice as long as the short leg. So back here we had 1 and it got doubled. Here we have 3 and it got doubled. And then our longer leg is root 3 longer than the short leg. Right, so if this was 3, the long leg would be 3 root 3. If the short leg in the small triangle was 1, the long leg was 1 root 3. So that is a relationship that we wanted you to notice in 30, 60, 90 and 45, 45, 90 triangles.